if for some weird-ass reason you have to leave early, like your butt's on fire, when you get up, don't let it go whack, whack, whack. Hold it with your hand so we can't hear you leave. It's very distracting. So, having said that, I'd like to welcome Shawn Gehle back to K-State. Yes, Shawn is one of our own. He graduated in 1999 after winning one of our most prestigious design honors, the Hanselman Prize. All of you can compete for in your 5th year. I admit I lost track of Shawn for a while, but I began hearing his name here and there about some of the great work he was doing, such as his time at BNIM in Kansas City. In 2006, I heard he had joined Gensler in Los Angeles and was doing very well. I love hearing how our graduates have taken their K-State education and found success, particularly if they had me for a studio or a critic, because I know I didn't screw them up too much and they were able to recover. So, well over a year ago, I received this little book in the mail from Shawn, and it's called Ideals 4, and it's something that they publish in the studio he's in every year. It was awesome, especially since I love getting free books. And they have lots of pictures, so that's always good too. It seems that Shawn in the ensuing years had become the principal and design director of Gensler's multidisciplinary studio in Los Angeles, and that they published their work in these ideal books. When I started looking through the book, I found it incredibly well done, and I thought, we have to get him back here and talk about what he's doing. When I made it to the end, though, I noticed a quote by the late Steve Jobs on the back cover, and I'd like to read that to you. Actually, it's in funny ink, so I won't from there. And the quote goes, "Here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes, the ones who see things differently. They're not fond of rules. You can quote them, disagree with them, glorify or vilify them, but the only thing you can't do is ignore them because they change things. They push the human race forward, and while some may see them as crazy ones, we see genius, because the ones who are crazy enough to think that they can change the world are the ones who do," end quote, Steve Jobs. This really struck me, not because I think Shawn's crazy, but because in many ways, positive ways, that is how I recalled him as a student, and I was happy to know that he had found like-minded team at Gensler to shake things up. And in doing so, Shawn's work has won numerous awards and been published widely. He also finds time to share his expertise with students doing studios at Cal Poly and sitting on guest reviews for USC and SciArc, to name a few. Well, it took a little longer than a year to get him here, but I'm very glad we did, and I think you'll very much enjoy it. So please welcome Shawn Gehle.
I think this room looked different the last time I was here. I think there used to be a stage, if I'm not mistaken. Well, thanks for having me. This is really familiar. I remember sitting in those seats and being here for lectures not so long ago. So this is a very familiar but I think odd experience at the same time. I'm going to sort of frame Gensler Los Angeles in the context of Gensler as a whole, just briefly, so that you understand what Gensler is and what its history is known for. So in 1965, this charismatic guy here on the left founded Gensler. His name's Art Gensler, and as I was mentioning to somebody just earlier before, he started his practice right at the time where the US tax code was changing. It incentivized companies to no longer own their buildings, but instead lease them. And it was just about the time that Knoll and Herman Miller were standardizing office furniture, and it gave birth to what is known as corporate interiors. And Art built an entire model around this, and for quite some time, the company was known for that. Since then, it's expanded. It's doing a much broader set of work other than just corporate interiors, and that it has expanded into a global practice focusing on both planning and strategic consulting. There's a number of things about Gensler, and I'm going to kind of give you an overview quickly, and then I'm going to get into more specifically the work that we're doing in LA. But we are a large firm. We're located in a number of different cities, and we focus the work around what we call our three basic markets or sectors, and they include practice areas, which are client types, And why these are important is that they are very specific to the way that you may think of as students your programs. We were talking in one of the studios earlier about doing retail project and a housing project, and what would it be to have a hotel, where at Gensler we actually have people that they are focusing, and these are people who have built a very long career over building expertise around a topic. And they add to the mix on projects to live that credibility to not only our teams, but to the design ideas that go into them. We're 100% owned, so what it means is that everyone has a stake in the ideas that come out of the office and out of the firm. And I think this is important because it also goes back in terms of the way that we build our teams, which is very flat and very non-hierarchical, especially in LA. We are now working in 86 countries. We have, actually this number is incorrect because we just crested 4,000 people worldwide in the last few weeks. And we now have 46 offices worldwide. And the reason this is important is that this allows us to do work at a totally different scale than most people can imagine. And most recently, what it's allowed us to do is to focus on this project in Shanghai. For those of you who don't know, we're working on the second tallest building in the world, which is the Shanghai Tower. If you read ArcDaily, Dezeen, Gizmodo, Engadget, any of these websites, you know that there were these two crazy Russian kids who just basically climbed to the very top of this tower, hung out for a day. Yes, that was Gensler's Shanghai Tower. The way we've approached this project is that we have pulled in expertise from each of these offices worldwide and looked at the design from a number of different ways, and I wanted to share a little bit about that. So for those of you who have been to Shanghai, this is in the Pudong district. The tower is just over 600 meters tall, 632. It's a hybridized building program-wise, which is retail, office, hotel, apartment, and it will contain the highest observation deck, public observation deck, unlike the Burj, in any building constructed. The way that we've gone about it is look at it from a scripting and formal standpoint to optimize the structure around sculptural form. So what it is it's this, let's see if I can get the, there we go. So what you get is this sort of guitar pick-like shape. As it rises vertically, it both twists and it tapers. The reason that that is done and the way that that is managed is it's done through a Grasshopper script. This is the script that builds both the form and it also builds the panelization that we ultimately exported into Revit, which I'll talk a little bit, technically speaking, how we move from one piece of software to the next. That form is then optimized through simulation. So what you see are varying differences of the amount of twisting that goes on. After we do that, we also talk about the amount of tapering that happens. Each one of these subtle variations allows us to remove structural steel out of the total equation because the biggest load on super talls is wind load. So the more we can make it aerodynamic and the more that we can allow it to basically act as a fin and a blade inside of the air tunnels, the less steel we can pull out of it, less steel, less cost, and ultimately more likely to get built. So here are the wind tunnel tests. These are actually simulations. We also do them physically so that we're coming back and forth from the simulations, modifying the model. Those models then get produced into a wind tunnel. That tower that's there in the middle, which this is our tower here, is about a 20-foot tall model. You can see all the wind points that are out on the perimeter. So this is really leveraging global expertise. There's people from Los Angeles, there's people from San Francisco, there's people from New York, London, and Shanghai, all working on this tower through the early parts of design. As we went into documentation, a team coalesced in Shanghai, worked on the documentation, is still working on the documentation as we wrap up exterior enclosure and work through CA. This is the final wind tunnels test. This verifies ultimately that the form is right, but I think you get a sense of the overall scale of some of the models. The panelization, we use a lot of scripting in our studio and across the firm as a whole. What you see on the right is a first pass at panelization to make that shape. What you see on the left is an optimized version, which basically allows you to take the triangulated shape or the trapezoidal shape and unitize it so that you can get a standardized shape across the entire surface. This is all done through Rhino and then exported out to Excel to verify compliance. And then it's exported into Revit. And we document ultimately everything inside of Revit. I don't know When I was here, I actually drew stuff by hand for part of the time and drew part of it in AutoCAD. But we primarily model early on in Rhino and then document everything in Revit, and there's a really clear symbiotic relationship between the two, which I'll get into a little bit more detail. We also coordinate that with our consultants, so you'll see full 3D modeling inside of the tower and inside of the projects, so they're fully coordinated models. And then we do that with structural steel as well. And the reason that the steel is so important is that in a super tall, the members are extraordinarily large, as you might imagine. So big that they need to actually be coordinated in terms of being able to be driven down the road. So you'll see the part on the left here is then put into place, and you can see that's a person right there. That's a beam. And these are simulated. Again, simulations are run from the steel yard all the way to the job site, and they use our models to coordinate that activity. Just a little bit more in terms of the logistics. The way that ultimately the contractor won this project, I think, is really interesting. They were able to take our model out of Rhino and ultimately run simulation on it for tower cranes. For any of you who have ever seen a tall tower go up, there's ultimately a crane at the very top that picks everything, pulls it up to the top, and keeps going. They won because they had figured out how they could ultimately get 4 tower cranes on top of the tower. All 3 losing teams could only get 3. And then we take that same piece and we work through SolidWorks, and in this case, Inventor with the subcontractor to go through mullion and extrusion fabrication, and then these are the shop panels that occur. And this is it under construction, and this is just a little old. We actually have a bit of an issue sometimes getting images, updated images out of China. I sometimes find images more quickly on Flickr than I do within our own office. But we're structurally all the way to the top, which is here. When the building's completed, it'll be the world's largest double-skin facade. Each one of these waistbands is effectively a mechanical core that supports a stack of a building here. In the event that there's a fire, people are able to egress down to these. It's part of the Chinese building code. So, I was talking global and starting to get a little bit more specific about how LA works. Los Angeles, I was just talking to Tim here earlier. He said he'd been to San Francisco, and for any of you who have ever been to any of the Gensler offices, they're all very different. They very much represent the kind of culture that they are embedded into, and they are made up of folks who are very familiar with those cultures. And this is what our LA office looks like, and this is us. We're now just a little bit over 400 people. And our space has been used for a number of different things, but I think the thing that I would be most excited to share is the way that we actually use our space from a fabrication and prototyping point of view. So this is our model shop. You can see sort of model storage on the left, and then we have a whole wood shop to the right. We also have a whole prototyping space that has 3D printers and laser cutters. But those technologies are ultimately what are empowered by what goes on at the desk. And so I was telling somebody before that, my studio is basically this crazy motley crew of folks that come from the entertainment industry. They come from different academic institutions, both with architecture background and industrial design backgrounds. But they're dealing with a lot of different issues. So at the bottom down here, you'll see a gimbal. A gimbal is a hanging device that allows you to level off cameras. We're actually using that in combination with a hexacopter because we're dealing with 3D printing prototypes. You'll see a lot of models and iterative studies around the studio, but I just want to sort of give you a little bit of an idea of the way that the flavor of the office as a whole. It's also really influenced the way that we approach the work. I think historically we sort of saw this sort of designer input devices, pen, paper. This gets back to a conversation I was having with David Sachs and Torgare at lunch. The sort of idea that so many folks had sort of learned how to write before they learned how to use a mouse. We're seeing that flip really occur, and now the question is, can you actually use the design data that comes out of that to really inform the designer and actually put something that's sort of a scripting language that has a recursive quality about design information, allows you to refine it, much like what you saw in the Shanghai Tower in terms of the shape making. So it becomes a sort of computationally heavy piece. This is probably no more evident than the work that we've been doing on the Farmers Field. This is a new NFL stadium in Los Angeles. We don't have an NFL team yet, but I know that it's coming soon, hopefully. But I want to just talk a little bit about the way that this roof is made. So this is Farmer's Field. It's a pretty simple structural problem. Basically, there's no columns anywhere over the field, so you have these two long spans on either side. They need to ultimately bridge from end to end. There's also the piece that goes at the very edge of the bowl, which is the green piece. At the end of the day, those are two very long super trusses. Those super trusses then have a fabric piece that comes across and a piece that runs along Chickern Drive. We saw this changing over and over and over as we were reconfiguring the bowl design, and so the amount of structural steel that was in this, again, needed to be optimized. So we ended up writing another script for this. This script ultimately controls the structural language of just the frame, the superstructure of the lid for the stadium. And what it generates is ultimately this right here. And I say that because while it goes so fast when you just run it through the slides like that, it never goes that fast when it's like, I need to move this column out 3 feet. What's the implication of all of that? And so without scripting and without being able to sort of make those larger changes, I think we would be in a totally different state, but we're able to now do that in a fairly aggressive way and then export that material back out into Revit. So it generates geometry. Those geometries are used for renderings, and this shows you a final image of the way that kind of structural piece works. I'm going to go a little bit different scale. So this is going all the way down to a memorial that we worked on for LAPD. This also talks a little bit about our own process in terms of the way that we approach the design process as a whole. So this is the new LAPD headquarters. On the other side is Tom Main's Caltrans building. Our memorial is right here. You know, we opened this up to the studio as a whole. I mentioned this idea about sort of best idea wins. It's really getting all the ideas out and you know, expressed. Taking those, assembling them into sort of big buckets. So in this case, there's sort of 4 different, you know, major themes. Teams sort of coalesce around different ideas, and then understanding what the actual program and site condition is. So in this case, this is a very public space. This is a very private space. The LAPD had very significant concerns that there were no points where people could hide behind this thing, and it needed to be an evolving piece, something that would represent and be able to be a living document of, you know, the service that the LAPD offers the community. So the condition here is that the garden is the privatized space, the memorial is the public one, and there's this demarcation piece that really divides the 2 pieces. You can see Tom's project on the left here, and the landscape piece, which was already in place before we started. We just knew that this was our site. The approach that we took was this idea about kind of memorial typologies that had changed over time, the notion of stacking, and then the idea that brass has a very important relationship in terms of the police force in almost any community, and what the nameplate represents in terms of the identity of a fallen officer. This was the concept model that we showed to LAPD, a lot of physical models. This is very simple, but the notion of brass very much resonated with them. This was the concept image that we proposed. Each one of the plates is, again, scripted and managed so that we're able to ultimately not only water jet cut portions of the logo, but we're also able to put names in. We worked with Zahner on this. We exported our Rhino model directly to them for fabrication. This is a really cool story being in the Midwest and telling this because they actually fabricated in Kansas City, put the whole thing together in one piece, took their picture with it. Then the Kansas City Police Department gave it an escort all the way to the state line. And then when it was received in LA County, the LAPD did the same, received it, brought it all the way into site, picked it, and hung it as one big object into place all at one time. It really, for me, I think underscores the scale difference that we're dealing with in the studio, which is that we are jumping from very large scale, very big, complex problems in buildings to a very small object, memorial type, you know, resolution. And that kind of scale jump, I think, is what keeps things exciting. It's, I think, one of the perils of being in large offices that things can get fairly monolithic in a way, and I think to Matt's point earlier, I'm probably the agitator who does not like that as a result. But you can get a sense of the way that light comes through each one of these pieces. This is the shadow beyond. There are a series of solid ones that are then pulled off, water jet cut, and then their data service put inside of it, the final image. So the next project I want to talk about is actually an academic partnership. Myself and one of my colleagues do a number of these academic partnerships, in this case with Cal Poly San Luis Obispo, both around material and also city and urban issues. In this case, it's the material studio. So right before we were moving in, we took on this idea of having a communal table in our office. I had 3 students from the digital fabrication lab at Cal Poly San Luis Obispo selected for this studio. We gave them a program that we just needed to basically have something that we could put printed material out on, be able to have it as a receiving table for people who came, and then we were going to be using solid surfacing material. So these are the 3 students. These are their 3 individual ideas. What we did is we took each one of their ideas and reviewed them via GoToMeeting. So this is a completely virtualized studio. They were in Cal Poly San Luis Obispo. I was in Los Angeles. I brought it on a senior designer, and we would give them basically desk reviews via GoToMeeting twice a week. For their mid-review, they ultimately sent us a 3DM file. We took that, ran it through our 3D printer, and on the fly basically had their 3D print on GoToMeeting video and reviewed their design while they were in San Luis Obispo. For us, as a global practice, that's a very familiar and common thing. For them as students, I think it was a pretty extraordinary thing because they were not used to presenting off a GoToMeeting. But we ultimately took their 3 ideas, combined them into one, worked with Burrow Happold, who we have a really great relationship with, and Greg Otto, who is involved there and who is also an undergrad K-State graduate, helped us work on the structural sort of underpinnings for this. So what you see is a plywood underbelly. The top basically works as a large diaphragm. There's a continuous nail rib that goes down the top of each one of these pieces. There is one piece of steel that runs down through the middle. It's a pretty ambitious cantilever because it's actually in the shape of an S. The egg crate is loose fit, which means it's not glued. And then every single piece was then sent to the fabricator as a file of fabrication model. So this is full-size waffling. This is Baltic birch plywood. The pieces were cut in halves, assembled upside down, pushed together. Ultimately, you see the strap that is running down the length of the top and the steel that is ultimately encased in wood as it goes down through the middle. At the same time this was happening, we took solid surfacing and started to form it. We created a partnership with LG Houses in this project, and they loaned us material engineers and material scientists that knew their material backwards and forward. They gave us the documented limits of materials and then said, this is where we tell everybody you can't go, and this is where we know is actually failure. And the brief to the students was, you have to operate in this zone. If you operate below what's documented, we haven't gone far enough, and if you operate above the point where they're telling you it's failure, we are going to break stuff. So you have to operate in there. So, so these are the forms. This is high-density foam that's milled out. You start seeing clamp molds to ultimately wield the solid surfacing into material. Once you do individual panels, you then thermally weld them one next to each other. Those are hand fused together, welded, and then held into place. They're ultimately put onto the table, hand buffed out after the thermal welding occurs, and then it was created as one big 18-foot long table and brought into our office, which you can see it down here, maybe at the very bottom, but this is the final result. this is just an example of what I think has been a really great success over the last few years of our office getting really tightly involved with academia and not looking at relationships as something where we are just merely contributing either financially or just our time, but this is where there's a symbiotic relationship of us basically being able to make things happen, students learning, and a manufacturer donating materials to allow things like this to go on. It's a total win-win for everybody. So the next project I want to talk about is Santa Monica College. This is a project that is currently just wrapping up permit review, and I want to talk about the cladding that's around the outside. When we started this project, it came out of a lineage of a series of investigations around perforation. And this is a thing that goes on in the studio a lot, which is that we'll find ideas, we'll look at things, we may not be able to implement them on a project, but we basically park them and we keep them in terms of an investigation line that we can rebirth and look at in the future. And it came out of actually an exercise with my daughter. My daughter was playing with a dough roller, and she was making cookies. And so the question was, she wanted to know if she could take the cookie cutters and put them on the dough roller. And it made me think, like, why couldn't you do that with perforation? And then it started making me think, like, well, why could you do it and not just perforate it, but actually have zero waste and actually tab and perf? So this was the original kind of modeling that we did. It results in physical models. So these are one of about 50 studies on texture and form. We reached out to Zahner. The idea was that maybe we could do this out of metal. You know, this was the one that we were ultimately sort of like really becoming enamored with at the time. Zahner was telling us that when you roll something over like this in one direction, you know, to tab this and to tab that in two different directions is pretty easy, but to do this one was really, really hard. So we got a price, and it was astronomical for this project, but it was an evolution from what we had looked at prior, so we shelved it. But we had already kind of pitched this idea to the client, so we were really on the hook, actually, to be quite fair. So we had to come up with a way to take this kind of idea and implement it, because they were under the impression that we actually knew what we were doing. So we started showing pictures like this to them, and the idea was that if we could use another material, in this case FRP, which is fiberglass material, we could not only you know, cut the holes, but with fiberglass we could actually do something else, which is we could form it. And when we would form it as an S-curve, it actually would give it strength. If you've ever looked at the way the curtain wall works, if you span curtain wall from one floor to the next, all the load is right there in the middle. What it means is the steel that goes vertical has to be extra thick. But if you make this 2 floors high, the load's still in the middle, there's a floor right behind it. It means that the floor is actually picking up some of the load, the wind load, and it allows you to thin things up. And so what we thought about was like, let's make the FRP have that same S-curve. That'll give us strength and stability. And then the forming of that out of FRP is where a lot of the cost is. The real economy is in the perforation. So if we water jet cut as opposed to form it, which was what the original idea was, what we could do is we could have a fairly high amount of variation. So what we would do is we would form the panel as a whole. It'd be a panel that could be repeated. And then the X's would be water jet cut, going from very small to very large. It meant that the economy was in the forming and the perforation at the same time. And we ultimately built a script to deal with that sort of Xing. This talks about the geometry of the ovals, how the X's are formed. Once we have those X's, we can then build a set of panels that go from from bottom to top. These panels are built in Rhino. They do sit inside of a Reva model, which I'll show you, but this is ultimately the 30-foot tall span. This gives you a sense of the sort of gradation that you begin to see and the amount of topography with the isocurve lines there on the left. This is the paneling as it wraps that portion of the building. And then these are the prototypes. So this prototype is about 8 inches tall, 3D printed. We were having already sort of budget issues before we had started this, and so we needed to be fairly economical. So what you see there is basically Sarnafeld roofing material. If you use Sarnafeld roofing material in a quantity that's larger than 5,000 square feet, you can actually have it Pantone matched. So we used a red that was color-coded based on a northern exposure that allows us to get this amount of pop out of it. So what you see is basically exposed roofing material with a white FRP skin as effectively a brise-soleil. We take those panels, they get put into the Reva model as a curtain wall family. They're cataloged. This allows us to communicate with the fabricator exactly how each one of these panels are made. We also share these from a fabrication point of view in terms of the way that they're produced. Each one is able to be cataloged, and those are sequenced in terms of a large sheet here, which talk about overall shape and size, also the amount of perforation and where it's located on the building. And then the bottom is a series of solid ones without X's. Instead, it has a series of weep holes at each one of the valleys. Once we had the buy-in from the client who now knew that we actually knew what we were talking about, we had an FRP mock-up made, which is a one-to-one mock-up. So the size of this is actually 30 inches tall by 30 inches wide. The end to out, meaning the height from the valley to the ridge valley is 8 inches. It's a 4-inch off-center separation. And then each one of these X's is water jet cut after the panels are made. And this is the documentation that's in the CD set. The other part of this is that there's a series of glass curtain walls next to it. And we had an issue because this was actually part of a dance studio. There was privacy concerns about people being able to look inside of each one of the dance studios, and so we needed to come up with some notion of a scrim. There was a very early idea of actually running that FRP past and gel coating both sides. It was cost-wise did not work, so we ended up dealing with a frit pattern. So what we ended up doing is taking the X's that we had developed from the perforation that already had their own kind of logic, and then creating a system that basically would allow it to gradiate based on its proximity. So around each one of these is basically another series of X's that combine. The farther you get away from them, they shrink, and what you get is an effect where you have very small X's that combine, and then you start to get O's. The bottom portion of this building is, by the way, the football team, so there's this whole kind of XO parity between trying to make the dance folks happy and the football players still feel like they're like football players. So you get a perforation or a frit pattern that starts to have a quality of this, and then it has proximity based on the other ones. So you start to get very high levels of concentration, which in fact relate to the way that topography works in the FRP paneling. And you get results that look like this. This is 30 inches by 30 inches tall. You then combine that all the way up using the same perforation. Again, these are all able to be sort of tailored out and back and forth using grasshoppers, so you'll see kind of density qualities change here. And then we take a piece of plexiglass and we basically look at each one of these patterns individually. The client liked these so much that we ended up having them printed and framed for them as art pieces. So there's a number of these studies that are actually framed. But what we took ultimately in our own shop was pieces of plexiglass and laser etched them. This is a laser cutter running for about 26 hours each panel. I don't know if you've ever smelled the fumes off of a laser cutter running for 26 hours, but it's not positive. But it's a pretty amazing effect. So these are the close-up images of the scored pieces. And we started looking at overlays. We also started looking at what the effect of was from a distance. So you start to see the shadowing effect here, kind of resolution issue on that side, but you can see the effect on the inside. And then as you get closer, what the quality is. So I want to jump back to a different scale, and this is going to be a series of projects that all have a relationship to one another, and it comes back to a project that we're working on right now with UCLA City Lab, which is our research partner on a future of office work, which is something that I've been involved a lot in the last year. And I think it comes down to being part of a office that moved from west coast or the west side of Los Angeles, very close to the beach. We're now in downtown. And what does it mean to be in the Central Business District? And what does it mean to sort of make a scale shift? And we started playing with this idea of city building desk being the new version of CBD. And that desk was really about your workspace could be anywhere, but that there would need to be a very clear separation of kind of scale logics associated with CBD thinking. So the future of office work resulted in this book. Matt, I'll send you a copy. And these series of timelines. This looks at, in red is the influence of the city, the brown is the building, and the desk over basically the 20th century. It's major advancements between each one of these different disciplines or factors over time, and major kind of ages. So what you'll see is in downtown Los Angeles between 1870 and 1890, there's an enormous amount of growth. It's remarkable to think that this can happen only when you go to Shanghai or Beijing and seeing this exact same thing happening right now. But by the earliest part of the 20th century, the office building was sort of establishing its presence. It was beginning to figure out the models of efficiency based on standard planning. This really comes out of models of manufacturing. This also lends itself to sort of the lineage of Gensler in terms of the kind of history and topic. By the 1930s, there's standardization in office furniture. This begins to correlate with the GSA, which is the General Services Administration, starting to look at kind of office planning standards. And by 1939, you have Frank Lloyd Wright's Johnson Wax building, which is arguably, the real sort of first image of kind of unified corporate culture, kind of the one big work floor. Why this is important is that by 65, the tax code changes that I mentioned really start to force a totally different logic of office buildings. And for Gensler, that just so happened to coincide when Art Gensler founded the firm. It's probably, no accident that this office also birthed basically the beginning of corporate interiors, which is where Gensler really obviously got its start. But for me, most sort of significantly is that in the mid-70s, you start to see mobility come online as topics that people are talking about with the Digilog briefcase portable. I can't imagine carrying that thing. And then by 2000, you have the promise of the internet and what it could potentially do in terms of mobility and kind of a nomadic workforce. So this brings me to the issues of cities. We started a studio about 1.5 years called Capacity, and it was really interested in how do cities evolve, how do cities densify, especially in North America, and specifically in Los Angeles. What we were really interested in is understanding what was the capacity of downtown Los Angeles to grow, to really densify. Let's see if we can start this back up. I had to hit something, or I can see it on this. I can.
Brief question and answer while he's not doing the interregnum.
I can see it on there, so. Sure, yeah. Sorry.
Sean said we agreed that we'll have a little interlude here. He's agreed to answer any questions we might have while we wait for technical support. Illuminated.
It's certainly better than doing like interpretive dance. You have a question?
Yeah, how do you spell your name?
My last name is Gehle, G-E-H-L-E.
Now a follow-up question.
I'm waiting for you to ask, like, what's my social security number? Yeah.
For the dancing football building,
Yeah.
I don't remember what it's called, but for the Santa Monica College.
Yep.
For the pattern of the X's on the facade, not on the glazing, but on the facade itself, you showed an image where the sizing or the basic effective diameter of those X's was growing and shrinking. Was that based on some type of thermal analysis, or was that based on purely like a pattern type aesthetic?
It's not based on thermal analysis, although one of the issues that came up as we started designing it is that NFPA, which is the National Fire Protection Agency, there was an issue with the sort of number of air exchanges that can happen inside of that. So we had to ultimately throttle it up and down based on how big it was, but no, there was no, it's not a performative thing.
Any of the facade performative?
I mean, the FRED is, because we have a fairly stringent energy code in California, so the amount of opacity that you want out of that has to get pretty high so that you can have larger amounts of glass. But it was not sort of driven by that. So let me see if I can continue this. I'll try to keep the pace and we'll go through this. So, okay, so capacity. So capacity was done as another academic partnership between Cal Poly San Luis Obispo and Gensler Los Angeles. It looked at the sort of overall ability for downtown Los Angeles specifically to densify. You know, there are a number of things that ultimately affect capacity, but the real question for us was sort of where does it go? There's some really important big picture numbers here that reference later on, but you know, California is roughly 38 million people statewide. LA County is 10 million people, and the city of Los Angeles, which is that kind of darker brown area, is 3.8 million people. The site that I'm going to talk about is that black dot. So in downtown Los Angeles right now, there's 450,000 daytime workers and roughly about 45,000 residents. The great thing is the residential population in downtown Los Angeles is growing, and it's growing pretty rapidly. But our real question here was like, how much could actually be built in downtown Los Angeles? Probably one of the main governing factors of building in North America and in most municipalities is FAR. You know, FAR dictates what the floor to area ratio is for a given site. You know, if you have 5:1, you can do, you know, maximum 5 floors. Half of that would be, you know, 10 floors. You build on a quarter of the site, you can do 20. In LA, there's a thing called TFAR, which is actually, if you have an existing building that you are not utilizing all the FAR, you can make some money and transfer that to somebody else and build something even taller on top of theirs through entitlements. These are the FAR zones that exist in downtown Los Angeles now. This has historically been the kind of industrial area of downtown. This is the Alameda corridor and the LA River. There's the train tracks along this side. The red area is the historic financial core, and this area is where Farmers Field and LA Live, which is a large tower that Gensler completed. The rest of this is sort of the warehouse district, and you can see the difference between all of these. So FAR, if you took all the FAR that was available in downtown Los Angeles, it's basically 1.4 billion square feet. And to give you context, there's only 10 billion square feet of office space in all of the United States. So this is a pretty astonishing number. It's 360 Burj Khalifas, which is the tallest building in the world. I probably should use the Shanghai Tower for this, but let's focus on the world's tallest building. And to look at that, That's nearly 4.3 million people, which is the whole area that LA City, that larger brown area that I showed you before. It's an extraordinary number when you compare there's only 450,000 people downtown. So clearly something is off with FAR in terms of it being a limiting factor, so we wanted to focus on resources. We looked at primary uses all across downtown, hotels, offices, retail, residential. Ultimately, we focused on just these that are highlighted as 3 primary consumers of resources. And the question was, what was the resource consumption per person per day in downtown? We started with each one of those variables: water, electricity, natural gas, how much waste did they create, and what was the parking demand to fill the program requirements. And then figure out basically, and these are all off of very public based, publicly available information and statistical pieces that is all totally open source after we do these projects available. Where did each one of these projects kind of put the demand? So what you see is that hotels are very water and electricity intensive. You know, this is probably not surprising because, you know, most people go and they leave all the lights on and they take long hot showers. You know, restaurants have an enormous kind of parking demand, you know, as does retail, which you can kind of begin to see the sort of shaping, and office and natural gas, which is based on the kind of heating and cooling loads. Most surprising for us was actually that residential generated the most amount of trash, and we think it's because most residential units don't have the sort of constructed recycling programs that are mandated for offices and residential uses in LA. So what are the limiting factors? We started off with the existing population at 450,000. This is what the urban form looks like in LA right now. If you take that up and you just use maximum height, which is 75 feet for the bulk of Los Angeles, leave everybody in place, you can basically support 2.6 million people. If you take FAR, that's the Burj Khalifa model. That's a lot of tall buildings. That'd be really cool. And then if you use electricity as a bit of an overlay and understand what the limitations are, you know, the city of Los Angeles basically produces a fairly significant of electricity right now. We carry a surplus, you know, of about 24 million kilowatts. With that remaining amount, you could actually support something that's 2.6 million. Knowing that energy demands ultimately are going to increase, you know, by roughly 2% per year, and knowing that general energy trends and energy efficiency is going to drop sort of consumption rates down by 25%, you can basically pop this number back up to 3.5 million. I say this very casually, but these numbers are were peer-reviewed. They were looked at. We've also made the whole kind of table that runs behind this, which I'll show you in a minute, publicly accessible, and ask for people to basically comment on the way that we've done the calculations, because our hope and what we've seen and what we had interest is that other cities are now inquiring about how to sort of run these same kind of calculations on it. The biggest thing, and not surprising, was Los Angeles is sort of water, starving for water, definitely in the case of the drought right now. We import all of our water. If you live in Colorado, we own your water. It comes down the river, unfortunately, but it's a reality of living in an arid climate. So current water capacity is like 1.3 million people, which is actually not far off from where we are right here, and it really puts the demand on relooking at the way that we think about water in LA. This gives you a sense of where our water comes from. The question was, if we recycled more of the water using different types of projects to do this, what could we do? Right now, we use 99% of our potable water goes to these kind of uses. It's a real shame because, you know, quite honestly, there's a number of these things other than kind of drinking water that you could use recycled water. If you did use recycled water for a number of those, you could push this up to 3.5 million, and it really underscores the fact that this is all limited by water. This was the work that you see here was a 10-week studio with 3 students. And I say that because this is an extraordinary amount of work and research that's done in that kind of time. This calculation in this chart is what we made publicly available. It gives you all the use rates on a gallons per day, you know, for each one of the use types. You can also plug in basically percentages and overall square footages and run your own models. I heard this described as kind of Sim City for politicians once. But the mayor of Los Angeles, we sent him the video, which we've done a number of these as videos. We sent him the video and just said, hey, you might want to check this out. And like 3 weeks later, somebody came out to me and was like, the mayor's walking around with your video on his iPhone showing it to people. And for us, that's a really great thing because it basically forces the conversation to start happening. We call these speculation projects. They basically prompt conversations that may not normally be happening. So this is the downtown residents population right now with 10%, kind of consumption rates, the total capacity. You know, what would happen if you start manipulating the kind of residential population, knowing that it's growing, you know, how population grows and how many cars come with that, as sort of standardized sort of protocols. So this ultimately becomes the driver at the end. It's always water. So the aha out of this for the city planners is that FAR in downtown Los Angeles is not obtainable, but it's all about resources, and it's changed the conversation for us in Los Angeles in a lot of different ways. So the next I want to talk about buildings. So when we moved 3 years ago, you know, this was the kind of space that we started seeing pop up everywhere. This is the 10 billion square feet office space that exists all over the United States. I didn't do this, so you want to try this again, Matt? This is actually a cool project. So if anyone wants to know my first name, it's Shawn. It's S-H-A-W-N. No, seriously. Are there any other questions?
Another question. What was the name of that book that you were talking about earlier? With these 3 scales?
So it's the future of office work. It's going to be actually a 3-volume project, and we're working on right now with UCLA City Lab Volume 2. So what we've been doing is we've been conducting a series of panels with a kind of 10-year window out with technologists, transportation experts and designers, and city planners to really think about, you know, what is the role of the city in the kind of office of the future. Talks about issues of mobility, proximity. I mean, we have a clear kind of culture of congestion to deal with in Los Angeles, and what the implications of that are, I think are pretty paramount. So the findings out of that will probably come out at the very beginning of next year. We're just beginning to sort of compile all the material.
I have a question. You are the director of design. What does that mean?
That's a fair question. So the actual title is design director. Just to get the nomenclature right. And what it means is that I oversee a fairly wide number of projects. I have colleagues in my office that also hold that same title, many of which are also principals in the office. And we are ultimately accountable for the design quality and design concepts for projects. It means that we are the ones who most often pitch to new clients. It means that we're the ones who are on a regular basis presenting the work. I personally do not run my studios in a way where I draw it and somebody else, you know, comes up and resolves it. I run my studios fairly flat. There are other design directors. We are a large office. There is no one singular person that does any one thing anywhere. It's all about multiplicity. But in my studios, it means that you have senior designers and job captains and junior staff that come in and work on projects, and we work very flat. So, does that answer your question, Torian? Well, I mean, it also means that it sort of set the conceptual framework for the studio. So a lot of the material and urban investigation projects are, you know, come from a very small number of people and are probably my own brainchild, but they're only pulled off because of an incredible studio of people. And so, you know, I would be, I'm hesitant to ever take responsibility for all of that, because the reality is what you see in the work here today is a result of a lot of people touching that work. I'm just, at this point, the one talking about it and fortunate enough to sort of spark it, to get it going. Let me see if I can race through this, and then we'll try to, it's not beating the clock, it's beating the projector, I guess, right? Okay, so let's see if we can do this. So when we moved, we took over an old banking hall. This was the space when we took it over. It was roughly about 28-foot floor to floor, glass on all sides. Imagine this filled with teller stations, bank executives, all the things that used to be in banking halls long time ago before ATMs showed up. When we moved in, it had been vacant for 10 years. And it was really, I think, a result of what the banking industry had seen, which is massive amount of change in the way that they conducted business, and it forced us to also think about the way that we do our own business. So when we took over this space, it was a freestanding building in downtown Los Angeles. There's two high-rises on either side of it. We're sitting on top of two restaurants below it. We did some fairly aggressive things. We cut skylights into the ceiling. We hung a floor, which is this. We cut a hole in the floor up above, which was all archive storage. We ultimately populated this building in a very different way. This is now an office building inside of what was formerly a banking hall. But a lot of the operational moves and the kind of communal spaces that resulted in this, which we use for very public functions. In fact, we have this space, which is one of our primary spaces on our ground floor. We let people come and use this space like 3 or 4 times a week for their functions. It's just our way to sort of give back to the community, for our staff to be able to interact with them. And it's a great space for us to get together, like the photo I showed earlier too. And it's a pretty fun place. I think it really ultimately grabs the way that we work, which is very collaboratively. There's a sort of certain amount of fun that goes on, riding bikes around. And it's a very kind of transparent culture in so many ways. It's always filled with activity, which is a great buzz to be around. And this is like the most clean stage shot I think we have, of the way that the studios work. We end up having chilled sails. These are a series of water fins that are radiant cooling, cool air drops. We take as much of the lighting as we possibly can out of the ceiling, and we bury it inside of our furniture. That allows us to amortize the cost of that lighting system inside of furniture. It's a purely financial play, although I think the design results is quite nice. And it expresses all this activity very much to the city. This got us thinking about this notion of hackable buildings. This is a project that we submitted for Office Building of the Future competition. The request was very clearly for a brand new building. This was not what we submitted. Our premise was that you would basically take old existing buildings and hot rod them. And the notion was that hackable buildings are these existing structures that can be modified beyond recognition and incorporate a very diverse set of uses. It was the initial operations that we had done on our own building that kind of birthed this. We looked at 12 buildings in downtown Los Angeles from 3 different eras, 1 from pre-war, 4 from pre-war, 4 from the time between the World War II and 1970s. This is when mechanical ventilation, vertical transportation starts to come online. And then the 1990s, where the basic floor plate of office buildings sort of stagnated, and basically the model was, from a cost point of view, just repeat it as tall as you can to get a lot of economy out of it. You can see the timeline is very small buildings, very tall buildings. The floor plate size along the bottoms, the overall height, which is the big spike here with the tall buildings, and the amount of elevatoring that's associated with that. The aha out of this was not all this kind of stuff, but actually this slide right here, which was the time that a lot of these buildings were being converted. So you see these very small buildings at the very beginning. They were being converted to lofts, to apartments, to hotels, but most surprisingly, the time from which they were built to the time that they were converted was slowly getting smaller and smaller and smaller, and so it really begged the question was what was going to happen with these tall buildings. And the reason we asked that question was not just because we were being asked for it for a competition, was because there was something happening. We were building a lot of stuff, and we are still in Asia, and that's because the supply there is very low, the demand is very high. North America, we have very large supply, and we have very low demand. There's 3 basic drivers in what's happening here. The first one is mobility, that whole kind of nomadic culture, everyone carrying an iPhone, an iPad, and a laptop. And then also issues of sustainability and speed to market, which is how quickly you can do things. Because everything that was once static is now mobile. You've put everybody into motion. Technology has totally transformed the office space. once you do this, the largest disturbance to sort of permanent office buildings is mobility, because it really forces you to rethink a number of it's like an egg timer. That's. Let me. If we get this up, I may just sort of skip a few renderings. Yeah.
That kind of analog of LA being the kind of total realization of the FDR of LA being unobtainable because of resources.
Yep.
Is that like an analog that's transferred to conversations with clients in Gensler's practice? And you kind of see it that way? Because I think that's another.
I think
at
we're.
a smaller scale, like that's a conversation I think building owners need to have.
Yeah, it's actually the conversation that the city wanted to start. Because I think what they realized is that their bartering chip, when we put this out there, kind of lost value. Traditionally, it's always been about FAR. I'm going to try to cruise through this as quickly as we can and see if we can race here. So companies are getting smaller. The amount of floor plate that they're taking is getting smaller. It's not that they're getting smaller, but they're taking less and less space because people are working in Starbucks, they're working in parks, they're working in all these places. So the question was what kind of happens to all this space, especially as you aggregate it out over the course of a city. Our idea was that you basically rethink that, and especially from a point of view of sustainability, because the most sustainable thing you could do, although building double skins and super high performance buildings is really cool, building reuse is probably the most sustainable thing you can do from a truly authentic point of view. And the real question was, like, do you really need a brand new building to support a mobile paradigm? So to do this and to really capitalize on speed to market, the notion was that basically what you would take on is a series of these small intervention projects. They could generate revenue fairly quickly. The cost could be pretty compartmentalized. They could be done over time as opposed to the kind of real effort that it takes to build a brand new building and the capital investment to pull that off. So there was a series of pioneering interventions that was put out. It's sort of related to cost, effort of implementation, really easy things like just changing the use to like getting more aggressive where you're starting to put like structural and operational changes inside the building. The most aggressive thing was we were going to run a transit stop underneath an existing building, which was astronomical. But it's things that we had seen and done in our own space, penetrating floors, removing floors. Hey, why not even make a floor movable in some way? Adding skylights, adding interfloor elevatoring, connecting and harvesting rainwater. This started to relate and make interrelation to the sort of capacity study and bring in natural light. So we applied this idea to two projects, one in DC and one in LA. What you'll see first is a project in DC. It's the J. Edgar Hoover building. It's a humongous building. It's 2 million square feet. The notion was that you could kind of incrementally do this by converting the uppermost level to soccer fields and reuse the rooftop garden, begin to pull vertical transportation on the outside. You get more aggressive, you start to remove square footage, you access the inner courtyard, and you start to get results like this, which now has retail all along the bottom, a hotel on the right, office on the left, and then that retail piece that we just talked about. And you can see I would not want to sit at the very end of that watching my kid play soccer. But you can see from this the views back to the Capitol at the very end, and then the soccer field at the top. We did the same thing with a project in LA as well. This is a tall building. This is the Union Bank building in downtown LA. It's 40 floors of, for the most part, the exact same floor plate. So the idea was much more of a sectional play where you start to have assembly spaces near the bottom and you sectionally change the building as you go up. It means you're putting things like, in this case, a kind of educational suite, amphitheater, we'll call this the big theater, not the little theater over here. And then communal education facilities, things that have very high assembly spaces. And then you stack vertically things like standard classrooms, fitness centers. You shove data centers in spaces that are really hard to lease because data centers, the positive out of there is that they will continue to grow. We see this all over North America and all over Europe. But the positive out of this is they produce a lot of hot water. Hot water is great for hotels. We just learned that in the capacity study. You can also run residential uses off of hot water uses. Maybe there's even a spa. There's traditional office, and you get farther up and you start to get more aggressive with the moves where they start to manifest themselves on the outside of the building. And brands no longer are confined to sort of this homogeneous sort of exterior, but instead they start to express themselves on the outside. The other thing is that you get this kind of layering that becomes very poly-programmed from the outside as well. And the notion was that if you take this principle, sort of look at it from a city point of view, do it with one project, you implement even something that allows this to happen over time, it becomes very iterative, and the city as a whole sort of takes on this kind of adaptive quality. So the last project I want to show is more focused on workspace, and this is the last one, but it's a project for a C3, and we were asked after we won that competition with the Hackable building concept, so like, do that with a new building. And it was like, but you're supposed to do it with an existing building. And they're like, but yeah, we want you to do it in a new building. So, we took a lot of the same premise, the ideas and what we were, being asked to look at for a lot of existing space in LA, which looks like these bowstring truss buildings. And we came up with this idea of C3. And this project is actually moving forward. It just went through entitlements, so it's actively moving very quickly forward. The premise here is that you basically are able to take the bowstring truss building, the whole idea of a private front door and access to parking, and replicate it, as opposed to replicating it in the sort of traditional suburban office park. You take everybody's parking and you co-locate it, you take everybody's bow truss building and you stack it, and that's the sort of conceptual diagram. It works pretty simply, and it works not far off from that, where you have a big workhorse piece of parking, a great public space in between, and then the most efficient floor plate, which is a square with a center core in the middle. The aha here is that in this case, what you'll see is that the floor to floors vary. So these are double height floor to floors, and then single height, double heights. It allows a high level of adaptability and customization. The whole notion here is that what we're able to do is sort of offer up a framework building at the very beginning, and then give a suite of tools and operations to tenants that they can then invest in over time, connecting stairs, private connectors from the outside, and you get this ultra adaptable piece. The big piece is also that, talking about FAR, the developer does not actually build to the maximum FAR at the very first day one. Instead, what they do is you build this double height space and you let tenants hang a mezzanine in the future. The reason this is a big deal is because, and we did this in our own space, we hung that mezzanine, we don't pay rent on it, we paid for it, but if we ever leave, it becomes an asset to the building owner, and so the developers really became quite interested in this notion. This whole idea of private front doors is a really big thing. What we keep hearing from more and more clients is they don't like the idea of going into one singular elevator and going up this, sort of commercial, piece, getting separated from each one of the floors. Instead, they want to see activity, they want to be connected. And so that is able to occur on multiple levels, and you end up getting a result that's sort of base building and then tenant customized on the other side. We also have fairly benign climate, and I want to thank you for giving me benign climate today. I hear you have had some pretty harsh weather, but this is pretty nice. But this is very much taking advantage of kind of indoor-outdoor relationships and the whole notion of kind of operability. So this was the space that ultimately we keep hearing from tenants they really want. And so this is the kind of space that we're offering up in that final project. So thanks. Sure, my middle name's Ryan. Sure. Yeah.
Are these like speculative type projects, and I think that's what Gibson's bringing up, is it something that is self-initiated, that someone within a firm wanted to study the potential future growth of Los Angeles and did that, or is it something that the city initiated?
Sure, so combination. So I initiated it, to Torgeir's question. The capacity piece. The project that's here is a developer, a client coming to us, having seen a speculation project, which was, or a competition submittal, I should say, which was the hackable building idea. So the hackable building piece goes out, it's a competition submittal, a developer sees it, they call us, say, we really like that concept, let's go over here and do a real project. And there's a number of those examples. I mean, the table is a really good example. So that table is in our front lobby. We've had a number of clients say, I want to do a table like this. Let's do something different. And so we go, and so they become in some ways, part of the lineage of investigation. It's like the perforation studies, but they are sparked. A lot of the studies are sparked internally. I mean, I will just say we very rarely have clients who come and be like, hey, I want you to study perforation, or I want you to study whatever it is. You have to layer that on the work. And for me in my studio, it becomes really important to have lineage between that and continuity. And so hopefully what you see today is, there's a lot of work going on globally in Gensler. Some of it's very large, like the Shanghai Tower. And what we're doing in LA is trying to knit together a body of work that, has material inquiry going on. There's city scale material investigation going on, and then there's built work happening. And it's kind of the balance of those three different levers over time that I think is making it it's been a really fun place to be in the last few years. So.
Do you think Gensler can do that because they are so large, or do you think that's unique to Gensler? Or just large firms that have a lot of resources and a lot of different people doing different types of projects?
I think it's one of the things around large firms that I, graduating, did not give large firms credit for being able to do. But because you have the capacity to do it doesn't mean that you're actually able to do it. I think what I will say is Gensler in the last 5 years has completely and totally kind of opened the doors for what I've been interested in doing, and I found a really fantastic platform to hire students that I've had and to be able to, put things out that I think are of value to the office and to the firm as a whole, and they've gotten on board with that. And it's why I've, sort of set down, the idea of having a studio there. It's been a really supportive place. There are a lot of very large firms. Gensler is clearly the largest by size and by revenue and by number of projects and a lot of different statistics, but the mindset there is really, is different, so, at least in my experience. Yeah?
I had a question regarding the hackable buildings and then this last project you're presenting, and I think some of your graphics are starting to hint at it, but is there a kind of kit of parts or guidelines, some kind of policy guiding how a client or how a tenant can modify so that it doesn't become this kind of ad hoc, informal mess?
Okay. So I'll give you two answers. The one is the city asked the same question, and the city was like, there are going to be guidelines here, right? That we want to make sure that we result in we want that image. I just spent 3 days in Las Vegas with Tony Hsieh, who's the CEO of Zappos, and Zappos is doing incredible work, but it's a free-for-all. And I think we as architects, in some way, in shape or form, have to come to the realization that there is both kind of object and aesthetics and kind of framework logics that we have the ability to balance, and that giving up a little bit of control over the object, for me personally, is a very liberating thing. Like, I don't feel the necessity to craft the object as the ultimate result. I really enjoy the idea of kind of empowerment structures, which is what this is, and the kit of parts allows somebody to do that. I've been pretty amazed by how tenants take over space and do things that are actually cooler than what sometimes we can sort of project onto them. And the thing is all these buildings, they evolve over time and they mature. It's kind of like probably sending your kids off to college. They just kind of change in ways you never imagined. But we try to keep it fairly simple, and we try to keep it legible. And in this case, there are kind of, I think at one point we had different kinds of stairs, and it was like, no. It's like all the exterior stairs are a particular kind. There's a palette of colors, so there is some level of predictability over that. But I'll say, this approach isn't any different than if you look at the way that inline retail works. If you look at the way the retail works, is that it's basically a framework. Whatever operator goes in there, they take it out and they occupy it differently. I just have a position that we look at buildings like as very precious objects. We have this notion of kind of like timelessness and permanence and all those kind of things. And we're coming to term with a lot of buildings that have a level of maturity that we could probably do other things with. So I will say that probably factors into the way the studio looks at the work as well.
The fact that you teach somebody, how much does this idea, sort of the hackable building or sort of the reconstitution of an existing building, how much of that do you think is of value to the architectural education? Because we don't teach it. We basically, it's okay, you got a blank site, build a fancy object,
Yeah.
let's critique it. What are the values that you have learned from that that could be translated into an architectural value for architecture?
Well, I think the feedback that I've gotten out of the studios that we've done the sort of Gensler LA combination studios, in this case with Cal Poly, and then we're just getting ready to start them with SCI-Arc as well, is that we're asking questions that are not sort of, they're not in a lineage of study that probably a particular academic institution kind of has momentum on. We're kind of coming in randomly, you know, which is a good thing. I'll tell you, when we did the hackable building study, it actually started off as a project called the Evolution of the Office Building, which was that kind of background study, like how big are the floor plates, all that kind of stuff. And the students were like, why are we studying all these existing buildings? This is like history. And then we got to like week 5, and it was like, okay, so here's the program. Your site's this building. I'm like, well, what am I supposed to do? Like, do the interiors? I'm like, no, you're supposed to like do some really cool stuff with this. That's not exactly what I said, but I said, you're supposed to do some really cool stuff with this. And they were totally like, first of all, it took an understanding of what building systems are, how they're put into place, what the logics of buildings are. I mean, it took a whole nother level of understanding to be able to basically modify. It's like you got to know the rules to break the rules. And that was something I think that we totally like underestimated. But when we got to the very end, and it was a successful studio in that I think we had a really good results in terms of the research, but the design proposals out of it, I don't think were as baked as they could have been in a 10-week session in that particular studio. But I'll say Cal Poly San Luis Obispo was like totally stoked, because I think it was the first time that they had ever taken on like existing buildings in that sort of way, big urban buildings. So I think there's really an opportunity. It also is regionally based. I mean, I haven't been here in 10 plus years. So, you know, I'm driving, you know, in, and all of a sudden it's like all this stuff's built, and I'm thinking, you know, I'm going to talk about hackable buildings. Like, there's no, you're modifying a little bit of building here, but you know, it's a different thing in LA versus what it would be in like Chicago. You know, you look at what's going on in Detroit. Like, all these things have very like regionally specific issues, and that's why the local part of Gensler is like really important, because you know what the issues are like in your own city. Some of them are extractable and are exportable, but not all of them.
Is there much international exchange within Gensler? I mean, do you bring Europeans to the LA office?
Yeah. So, I mean, a number of people who were working on the Shanghai Tower very early on in design, which were in LA, are now in Shanghai. You know, people will go to London. You know, I moved very intentionally to LA. I've tried to make every effort to make sure that I feel fairly grounded in LA. But yeah, no, there's a lot of exchange. You know, one of my really good colleagues who I had worked with prior and who I had come to Gensler after I came, just moved to Costa Rica. We have an office there. We opened an office up in Brazil. I mean, we have, you know, somebody's showing in Mexico City. I mean, we have a lot of offices. They're not all the exact same as this, but you know, they're definitely growing.
Well, it seems like you're spending a lot of time looking at information that sort of floats around in the periphery of architecture, and then sort of reallocating that information into architectural strategies. Why is that important?
You know, I get no architecture magazines. Like the kids in the studios, they'll look at like Art Daily and the Zine, and it's like just, I don't look at any of that stuff. Partially because somebody really importantly told me like early on, like, you're never gonna get clients from like talking to other architects. Like, just find a influence group that's outside of your kind of traditional. And what I find is those people, they're interested in a lot of other things. And to be quite honest, I am too. And for me, it's been a really natural thing. It's that I'm interested in science, I'm interested in industrial design, and those things factor in to our process in a way that I think what we're looking at becomes unique to what we're interested in. Because I think it's a real big danger is that it becomes self-referential and kind of derivative of the work that's kind of popular culture. You know, so I don't know, for us, we're continually looking at stuff that is not kind of in the, like, right in the bullseye of traditional kind of architecture study, but it is all the periphery stuff. And part of it is also because that's where the clients are, and that's what's influencing their business. If they're first movers in whatever they do, they're looking at the periphery. They're not looking at, like, trying to, you know, glean the margins right at the very center.
No, I think it is correct. If you try to argue architecture from the point of view of architecture, you're not going to be able to sell anything. So.
Yeah, and it goes beyond selling. I think it's just being able to sort of look at it with fresh eyes. Yeah, fresh points of view. Is there another question? Cool.
Well, I apologize for the technical difficulties, but thank you so much.
It's been a pleasure.